On October 20th, 2025, a single raw frame arrives like a contradiction. It is late. It is quiet. It is a night in northern Chile. The date matters because it sits 8 days before perihelion. The date matters because the world will lose sight of this object as it slips behind the sun. The date matters because what that frame shows does not fit the rules we've used to read the skies for centuries. The person who posts the frame writes in a small, steady voice that feels like someone knocking at a neighbor's door at midnight. Her name appears as Carla Esta. She is not inside a glossy observatory tower. She is in a converted farm outbuilding outside a town with clear southern skies, a place the stars come down low and honest. Her rig is humble and exact, a 150mm refractor fitted with a narrowband H-alpha filter and a cooled CoS camera, a setup tuned for solar outbursts rather than comet hunting. The FITS header shows coordinates that match NASA's ephemeris: right ascension 13 hours 48 minutes 57.33 seconds, declination -8 degrees 25 minutes 54.3 seconds. The exposure metadata logs 11:48 p.m. local time for that night. She posts the raw frame, she posts the header, she posts nothing more dramatic than a timestamp and a note that the sky was clear. The frame spreads across forums and inboxes and then into laboratories. The image is eerie in its clarity. In an inverted palette, the nucleus is a sharply defined dark dot. Around it, there is almost nothing. The coma is faint, barely a whisper of diffuse light. The expected fan of dust and the narrow ion tail that should stream away from the sun are missing. Instead, an unnerving column rises from the nucleus and points against every intuition toward the sun. A narrow, columnated jet, bright and regular, aimed sunward. It keeps its alignment across independent reductions. It survives different stacking choices and careful calibration. It does not smear with the field stars. It does not mimic hot pixels or readout streaks. It looks like a purposeful feature, not a random artifact. To understand why this matters, we have to remind ourselves how comets normally behave. Comets are not miraculous, they are mechanical. As sunlight warms frozen volatiles in a nucleus, ices sublimate and drive gas and entrained dust outward. That expanding envelope, the coma, swells. Radiation pressure and the solar wind push dust and ions away from the sun, producing two canonical shapes: a broad, curved dust tail shaped by photons and a narrow, straight ion tail swept antisolar by the charged particles streaming from the sun. Geometries can complicate appearances. Projection can foreshorten a tail. Oppositions can hide structure. But the underlying physics always points material away from solar heating. The tail is the comet speaking the language of sunlight and momentum. Carla Esta's frame speaks a different dialect. A jet that points toward the sun contradicts the simple physics of outflow and re-radiation. The coma is faint where, by every expectation for an object approaching perihelion, it should be brightening. The antisolar tail, the fundamental fingerprint of solar interaction, is absent. The feature is too narrow and too persistent to be a broad anti-tail seen in projection. It is too aligned with solar coordinates to be a random sensor blemish. If this were a textbook comet, the image would be a wrong answer. The community runs the image through the familiar gauntlet. First, geometry and projection. Rarely, dust distributed in the comet's orbital plane can appear to stretch toward the sun when Earth sits inside that plane. These antitails can fool the eye, but antitails are broad and diffuse. They smear like old wallpaper, not columnate like a penned line. Modeling of 3I Atlas's geometry on October 20th shows the orbital plane is nearly edge-on from Earth's view, but not perfectly aligned. The threshold for a striking anti-tail effect is not fully met. Even if projection contributes, projection alone does not produce this degree of narrow sunward focus. Then they test transient vents and outgassing. Comets flare. Fresh pockets of volatile ice can erupt, spitting jets of gas and dust that briefly puncture the coma. These vents are usually chaotic. They flicker, they shift as the nucleus rotates, they fade within hours or days. In Carla's frame, the jet persists across multiple exposures separated by hours, surviving independent stacks and reductions. A short-lived vent would change appearance. This one sits steady. It resists the behavior we expect from a transient outburst. Atmospheric seeing gets a careful look. Poor seeing smears faint detail into streaks. But field stars betray the truth. In Carla's frame, stars are round and consistent with the point spread function of her instrument under subarcsecond conditions noted in the logs. If the atmosphere were responsible, we should see the same distortion across the field. We do not. Instrumental artifacts are scrutinized next. Hot pixels, column defects, internal reflections, these are mundane culprits. Calibration frames can reveal them, but the calibration logs Carla posts are clean. Hot pixel maps, darks, flats, nothing lines up. The jet follows the comet across frames. It keeps pace with the target's motion. Electronics do not chase a moving sky object and then precisely mimic solar alignment. Chemistry remains the last obvious fallback. Comets can be strange chemistry boxes. Observations of this object in earlier months suggested an outsized role for carbon dioxide. Spectra from August and September indicate a carbon dioxide to water ratio approaching 8:1, one of the highest measured in any comet. Some high-resolution spectroscopic runs have hinted at metal lines. The preliminary reports speak of nickel detections and a conspicuous absence of typical iron lines, an inversion of the metal abundances we expect. If the nucleus vents a volatile cocktail dominated by CO2, or if exotic organometallic compounds are present, the behavior of dust and gas could deviate from canonical patterns. But chemistry complicates more than it solves. Even CO2-rich outflow should still be acted upon by radiation pressure and solar wind. Outgassed dust and ionized material should still show an anti-solar bias. Chemistry offers hints, but it does not explain the lack of any broad tail whatsoever while a columnated sunward jet endures. We have tried to reproduce the feature synthetically. We have reprocessed the raw fits with median stacks and mean stacks, with and without background subtraction, with different interpolation kernels. We have run plate solves and confirmed the nucleus sits at the RA and at Carla, posted. We have compared processing pipelines and asked colleagues to grind the same pixels. The column persists. That is what makes this image hard to fold into normalcy. The spectral whispers add a dissonant chord. Reports from professional facilities in the summer and early autumn note the CO2 dominance and unusual metal signatures. Carbon dioxide dominance to the tune of an 8:1 ratio against water is not a casual footnote. Nickel showing conspicuously where iron should stand does not fit our meteorite heritage. In normal cometary material, iron is abundant. Nickel typically rides in smaller proportion. The suggestion of nickel-rich outflow with suppressed iron lines is, if confirmed, an anomaly the composition models will have to reckon with. We annotate this carefully. Spectroscopy hints at the unusual. The data sets are being checked, rechecked, and awaited for peer review confirmation. Extraordinary anomalies require painstaking confirmation. Orbit context sharpens the stakes. This visitor follows a retrograde path, a trajectory that cuts against the grain of planetary traffic. Its orbit is roughly aligned with the ecliptic but retrograde, a route that has surprised orbital modelers. Its perihelion is scheduled for October 29, 2025, a moment when, from Earth, it will pass behind the Sun. That hiding matters. Ground-based telescopes will lose direct line of sight. Only spacecraft with solar vantage, SOHO's coronagraphs, the Parker Solar Probe, and a handful of heliophysics assets can keep watch during the critical passage. Those instruments are not optimized for cometary science in the way Hubble or the large ground arrays are. Their cadences and filters differ. Their telemetry windows are constrained. They can catch a dramatic outburst or fragmentation, but more subtle structural changes might escape them. The immediate watch list is simple and urgent. Photometry must be tracked nightly. A sudden jump in brightness could mean fragmentation, a new vent, or something shedding mass. Morphology must be compared across independent reductions. Does a classic antisolar tail reappear after perihelion? Do companion fragments bloom from the nucleus? Astrometry must be precise. Even a small trajectory shift could hint at non-gravitational forces, outgassing torques, asymmetric mass loss, or something more exotic. Spectroscopy must be repeated. Confirm the CO2-H2O ratio, measure the metal lines, and watch how those signatures evolve when the comet experiences maximal solar heating. And once the object reemerges from behind the Sun, the first high-resolution images will be decisive. A return of an anti-solar tail would re-anchor this visitor in natural behavior. Continued absence or new, engineered-like structures would force a different conversation. We say this with discipline. Extraordinary claims demand extraordinary evidence. The scientific imagination must balance curiosity with method. Exotic natural physics is a sober possibility. Unusual thermal properties, a cracked nucleus that preferentially vents in a focused direction, charged dust dynamics under odd grain size distributions, or unprecedented chemistry could conspire to produce the image we see. These are all scientific hypotheses that can be constructed, modeled, and tested. The alternative, that we are observing something built or engineered, cannot be ignored in the face of stubborn anomalies, but it also cannot be claimed lightly. Evidence has to be reproducible. Independent observers must confirm. Spectra must hold up under scrutiny. Motion must be coherent with forces we can calculate or else indicate new physics. Human moments thread through this technical accounting. Imagine Carla Esta at her converted outbuilding, hands inked with tiny grease smudges from equipment, the hum of a cooler and a cup cooling beside her. Picture the late-night forum where her post lands, where a graduate student in a lab at 3 a.m. leans forward and breathes, where an observatory scheduler in Europe rubs eyes and reruns ephemerides. Picture lab techs at monitors, eyes narrowed at spectral lines that don't behave. Picture families whose nights are punctured by instant messages. Did you see this? Is it true? The tension is intimate and global at once. Science is a human relay. One observer's quiet frame starts a chain of verification that stretches the planet. The stakes are both specific and philosophical. At the specific level, resolving this anomaly matters for our models of interstellar material, for our understanding of volatile transport, for the inventory of building blocks that arrive from beyond our system. At the philosophical level, it tests how cautious we must be when a single data point resists explanation. We do not jump to the extraordinary. We prepare for it, test for it, and demand that our instruments, methods, and colleagues rule out the mundane before changing our worldview. For now, the evidence is a challenge and an invitation. The raw fits from Carla Esta is not a closed case. It is a hinge. In 8 days, the object swings closest to the sun and Earth loses the ground-based eye. In those remaining nights, every image, every spectrum, every careful reduction matters. If the jet fades and a thin anti-solar tail blooms, we will fold this into an expanded repertoire of cometary oddities. If the jet persists, if spectral oddities hold, if non-gravitational accelerations materialize, then the world will need to pay attention with instruments, with models, and with the patience that good science requires. Carla closes her laptop and steps outside. The southern sky is sharp. She pulls her coat tight. She knows the image will be checked by strangers and experts. She knows that some will demand immediate certainty, and others will ask for restraint. She breathes the cool Andes air and waits with the rest of us, for the instruments to speak, for the sun to reveal or conceal, for the data to accumulate. Over the next 8 days, we watch closely, compare reductions, and invite verification from every corner of the scientific community.